Okay, today we will discuss about air separator and dirt separator. Okay, so I hope I have shared the schematic to everyone. Okay, this is one of the chilled water schematic layout, right? Where it consists of chiller, chilled water pumps, primary pump, secondary pump. Then you will be having a load like FCU or AHU or FHU. Then after that you will be having a pressurization unit, air separator. Okay, these are all the main components in the chilled water system. Okay, so we have seen like a chiller. We have seen different type of chiller. One is water cooled, and another one is the air cooled chiller. Then after that we have seen the pumps. One is a chilled water pump, and another one is condenser water pump. Then after that we have seen the cooling tower, right? Okay, so today we will discuss about air separator and dirt separator. Okay, what is the purpose of the air and dirt separator? Clear, right? Okay, I think I will be sharing one of the lectures, okay, for air and dirt separator. So you can see that this is one of the main component or major component in the chilled water system. Okay, the air separator is basically, it works based on low velocity vortex that allows air bubble to rise, okay, and be collected at the top of the unit. Okay, I think I have shared some video how the air separator works, like when the water passes through the air separator, the whatever the bubbles, okay, so that is the air, right? So that will be taken out, that will be separated from the system, and it will be taken out. Okay, so that when it after the air separator, you cannot see any type of air bubbles. Okay, so that is the separation is done by means of air separator, right? Okay, so you can see the benefit of using air separator. There are prevent air binding, reduces noise, improve efficiency, prevents corrosion. Okay, if that air bubbles goes into the system, right? Okay, now you can see the different type of air separators basically. Okay, if you go into the market, you will find a tangential air separator. Okay, so the tangential air separator, you can see the picture as you can see this one, right? When the water enters at one direction at the top of the air separator and leaves at bottom of the air separator, right? So this is one of the type. So that is what you can see in my lecturer, tangential air separator. So it basically, you can see it's the design. It's create a low velocity vortex that separates air from the water. Okay, so this is one of the system. Okay, you can see the advantages, effective at removing entertained air and debris. Okay, its application is normally used in chilled water system and also heating water system. Okay, this is just a small component which is installed in the chilled water network to separate air from the system. That's it. There is nothing big calculation or something like that. Okay, we have to see how to size properly. That we will see in the coming lecture. Okay, now you can see that there is another type called inline air separator. Right, this is one of the system. So inline air separator, you can see this is inline air separator. When you can see the pipe will be entered and leaving at the same in the same inline. So that is called inline air separator. Okay, both have advantage and disadvantage. Tangential air separator may have a better efficiency because it separates the air. Say for example, due to that path, okay, it can separate the air. Okay, maybe the efficiency of the inline separator will be lesser, but it is easy to install. Okay, so in other way, so both have advantage and disadvantage. So we have to see that based on the, we have to inline with the manufacturer. We have to see what is the best model suitable for my application. Okay, so that we have to define it. Okay, but both are same purpose, but you have to see that which type is best, better efficiency, better performance, space, okay, and maintenance, everything you have to see that, right? And if you go, there is another, it's not another type, it is a one of the medium. Okay, you can see that collision air separator, it is one of the, maybe it can come into the tangential or it can come into the inline separator. Okay, so this is one of the medium. You can see that the coalescing medium to gather small air bubble into the larger ones. So what it is doing, it is just collecting all the air bubbles into the bigger one, then it will release on top of the vent. So that is what it is doing. Okay, it's a one of the medium. Okay, so you can see that efficient at removing micro bubbles. Okay, and you can see that its application is for use for same for HVAC purpose or heating purpose, right? And there is another one is called a micro bubble air separator. It captures and remove air bubbles from the water. Okay, it's excellent for maintaining system efficiency and preventing air related. Okay, then So application is for same for HVAC purpose. Okay. So basically, if you talk about air separator, you have a two types. One is a tangential, another one is the inline separator. Within that, you will be having some medium which is used, and there is a micro bubble air separator which can remove air bubbles. Okay, or it can gather small air bubble into larger one, and it can remove it. Okay. So this is one of the manufacturer. Uh, uh, you can see that Precision is one of the manufacturer, and you can see that this is both inline separator and tangential separator. Okay. So whenever you do the selection, basically you can see that the maximum flow rate based on the design velocity. Okay. Remember, whenever you do the chilled water system, your velocity of the chilled water will be at higher, around in the range of 3 meter per second. Okay. So this is what is the purpose of 3 meter per second. Whatever the small scale particles or whatever the air bubble, it has to pass into the water, right? Whatever in your system, okay, say for example in your system there is a small air bubbles, or say for example you have some scale formation that has to be carried in the water towards the air separator or dirt separator, right? So that whatever the scale or whatever the air bubbles or whatever the scale formation or whatever the air bubble, that will be carried from the system to the air separator, so that in the air separator or dirt separator it can be taken away. Okay. So that is the design velocity. So you will be designing at velocity of, say for example, 3 meter per second. Okay. So that is a nominal chilled water system as well. Okay. Remember, whenever you do the flushing, your flushing velocity will be at 3 meter per second, so that it can carry, if any scale formation or if any air bubbles, it can be carried into the system to the wherever to the separator or air separator or dirt separator. So that is the purpose. That is why we are maintaining the velocity. If you don't maintain the velocity, the scale will be settled in the bottom of the pipe. Then there is a chance of corrosion, or there is a chance of damaging the pipe. Something will happen. Okay. So that is why you have to have a certain velocity in the system to carry your air bubbles or to carry your scale formation to the air separator or dirt separator. Clear, right? So whenever you design the air separator, you will be designing at 3 meter per second. Okay. Say for example, you might have seen somewhere in the system. Okay. Say for example, this is your velocity of the pipe. Okay. Say for example, 350 diameter based on the flow rate. Okay. Sometimes you may see there is a reducer towards the air separator, and there is a contraction or expansion in the air separator side. That is to create the velocity. Okay. If you create the velocity so that it can separate the air bubbles or the scale formation from the system, right? So that is why the velocity is designed at 3 meter per second. Okay. So you can able to size the inlet and outlet size of the air separator or dirt separator. When you design the air separator, you have an inlet size, you have an outlet size. Okay. So this inlet size and outlet size will be designed based on 3 meter per second. So this is the maximum velocity. Okay. And if you go further down, this is your chilled water inlet and this is your outlet of the system. And in this picture, you can able to see the dimension. You can able to select the model, right? Okay. Based on the velocity, you can able to select the model. Okay. And based on the model, you can able to size the air separator or dirt separator. Okay. Then if you go further down, let me open another picture as well. This is for the inline separator, right? So in the inline air separator, you can able to see the dimensions, model, pipe, which is optimum flow. Okay. For that particular air separator, you can see inside there is a mesh, right, which separates the bubbles or dust particles. Okay. You can see that optimum flow. There is a dimension. Okay. You can able to get the pressure drop across the air separator or dirt separator. Okay. This pressure drop is required for you to design the chilled water pump head. Clear, right? Okay. So based on the optimum flow, you can able to select the model. Okay. So this is the model, right? And you can able to get the pressure drop as well. Okay. Is there anyone doubt regarding air separator and dirt separator? I have a complete lecture is given here. Type of air separator, tangential and inline type. Okay. Similarly, if you go to dirt separator, the same purpose. You have a dirt separator. This is the dirt separator. It will separate the whatever the dirt particles from the fluid. Okay, the same as air separator. Okay, there is a benefits efficient, there is a improved system efficiency, because if there is any particles which enter into the pump or chiller, it will damage, right? They damage the coil or damage the impeller. That is why we are installing a dirt separator. Okay, in the dirt separator, again you have a centrifugal dirt separator, then coalescing dirt separator, magnetic dirt separator, combination air and dirt separator. Okay, centrifugal dirt separator, it uses a centrifugal force to separate dirt and debris from the water. This is one of the system. So this is a technology basically. Okay, then coalescing dirt separator use medium to gather small particles. So if you go to air separator, it is gathering small bubble to big bubble, right? Here it is gathering small particles to big particles, like larger particles. So that is the same coalescing dirt separator. Magnetic dirt separator, whatever the dirt coming from the system, that is a solid particles. So which is ion particles, right? So whatever the ion particles, that will stick into the magnetic dirt separator. So after some time, while doing the maintenance, you can just remove the cut off the magnet so that it can fall, right? The solid particle will capture in the magnet only, right? So the whatever the materials such as ion particles. So once you release the magnetic option, what will happen? It will fall into the drain. Okay, so that you can able to taken out from the system. Okay, so this is one of the dirt separator. Clear, right? So just to make it complete, I have prepared the lecture here. So you can go through this lecture. What is air and dirt separator? Air separator is to remove particles from the air. Okay, whatever in the system should remove the air bubbles from the system. Okay, then you can see the type of air separator, which is tangential, inline type. Okay, so here also you can see that tangential and inline type is applicable for both dirt separator and air separator. There is a combination also available, or separate individual separate system also available. If you go with air separator, you will be having a vent on the top. If you go with the only dirt separator, you have a drain valve in the bottom. If you go both air and dirt separator, you have a both vent and the valve on the bottom. Okay, it will be mixed combination. Okay, so sometime you may require air separator, sometime you may require dirt separator, sometime you may require both combination. So you can able to select based on your or based on your project requirement. Okay, so the maximum velocity is 3 meter per second. Based on that, you can do the sizing. So if you go to the one of the manufacturer, you can able to select the model based on the optimum flow. Okay, so when you know the optimum flow, you can able to calculate the velocity. So that will be the maximum velocity. So based on that, you can do the pipe sizing. So this pipe sizing will be used for your further connections. Okay, so then you can able to select the model. Okay, then you can able to calculate the pressure drop for the system. So this pressure drop is required for your pump head calculation. Okay, so you can go through this lecture, and I will also sharing some videos. Okay, animation, like how the air separator works, how the dirt separator works, and what is the different types. Okay, like you may in future video you may able to see one of the video I'm just preparing magnetic dirt separator, how the magnetic dirt separator works. Okay, I saw some video, I will be sharing that link, so just you can able to watch, right? Is anyone having doubt regarding air and dirt separator?